Hi class, this is Professor Latham. I'll now be doing a movie on computing the correlation coefficient. So we have a group of data values here. As a financial analyst is examining the relationship between stock prices and earnings per share. She chooses 15 publicly traded companies at random and records and companies at random and records for each of the company's current stock price and the company's earnings per share reported for the past 12 months. Her data are given below, with X denoting the earnings per share from the previous year and Y denoting the current stock price, both in dollars. And so we have a scatter plot here of the data. And then we have the X value, that's the earnings per share, and this is the price of the stock. And it looks like we have a positive linear relationship. So they want us to find the value of the correlation coefficient. And so when we click on list of formulas, that will help us find the value of the correlation coefficient. So let's scroll down. This here B1 gives us the slope of the least square regression line, and we know it's the slope because it's the coefficient of the X term, but we need the correlation coefficient. So let's go down. And there it is, sample correlation coefficient. This is the long formula for it, which is the X sub I minus X bar. And you say, well, Donna, what's X sub I? That's basically saying take a look at the first term and subtract it from the mean. Then take a look at the second term, subtract it from the mean for the X values, all the way up to the nth term. And similarly, Y sub I is take the first term in the Y column and subtract it from the mean, and so forth. And it turns out we have a shortcut formula for finding R. So if we scroll over here, that's our shortcut formula for finding R. So let's click on that, and it'll send it to the calculator. And when we look here, we see this symbol here. It looks like E, but that's the symbol for a summation. So that's saying take the values of X times Y and add them up. So when we look at the data that they gave us in ALEX, we notice they gave us an X column and an XY column, but they didn't give us an XY column. That means the product of X and Y. So we said, well, goodness, how am I going to do this? Well, you could multiply each of these values, copy this, paste it into Excel, and multiply each of the values. Actually, if you could copy it into Excel, you could find the correlation coefficient. But what we're going to do is observe something that's pretty neat. This is the formula for R, and so what I'm going to do is show you that there's a formula for B1 that's really close. So let me open up Word so that you can see the relationship between R, the correlation coefficient, and B1, the slope of the least squares regression line. And so now I have Word open along with equation editor. So I have R is equal to the summation of the X values times the Y values. And I'm just going to leave it XY rather than putting the subscript. Minus N times the mean for X, so that's X bar, and I'm going to copy that so I'll have that. Oh, you know what? I didn't copy the whole thing. So I have X bar, Y bar divided by N minus 1 times the standard deviation for the X values times the standard deviation for the Y values. So that's the formula for R. When we go back to list of formulas, we'll see that there's a formula for the slope, and it's very similar. And so let's scroll up for slope. Here's the slope. It's again the summation XY, summation of the product XY minus N times X bar, the mean of the X values, the mean of the Y values, over N minus 1 S sub X squared. So it looks very similar to what we have for R. So I'm going to copy that. And it's B1 for the slope, and the only difference is this is s sub x squared. And so we have that formula there, and you say, my goodness, these look very similar. Matter of fact, if I multiply this one by s sub x, one of this x sub x here will cancel with that one, and then divide by s sub y. And we got to remember that what I do to one side I should also do to the other. So let's multiply that on both sides. On the right hand side, the s sub x will cancel with the s sub x squared. And so what I'll have then is this one I can get rid of. And then this one here will cancel with one of the s sub x in the denominator, and so I'll lose that subscript. And that is identical to what's up above. So we can see that b1 times s sub x over s sub y is equal to r. So this is a formula that I sent to you, I believe, in an email. So r is equal to b1 times s sub x over s sub y. And you say, well, Donna, why did you need that? Well, I did not have that summation formula for xy. See the formula here where it has summation xy? I did not have that column in Alex. I did not have an xy column. If I did, it's a different way to do it. And I think I do that in part 2. Similarly, when we go back to our Word document, if r is equal to b1 times s sub x times s sub y, if I multiply both sides of this equation by s sub y over s sub x, I'll put a s sub y over s sub x, we can see here the s sub x will cancel, but if I do it on one side, I've got to also do the same thing on the other side as well. So let's multiply both sides by that difference, or that ratio, excuse me, of s sub y over s sub x. And so when I do that on the right hand side, the cancels, and so we end up with just b1. And so we have another formula. b1 is s sub y over s sub x. So we have those two formulas. R is b1 over s sub x over s sub y, or b1 is r times s sub y over s sub x. All right? And so, well, Donna, why would we want to use that? Well, in this particular problem, I believe they ask us for the slope and they give us r. Sometimes they ask for r and they give you the slope. So let's go ahead then and recognize that all we really need is the standard deviation for the y values and the standard deviation for the x values for our particular problem. So let's make sure. So yes, for our particular problem, they say find the slope. So they want us to find b1, and they tell us what r is. And we said that it looked like a positive linear correlation by looking at the dots. So we do. We have a number close to 1, and it's positive. So you can see here we have that r value, and we have that r value of 0.898. So we have r and we want b1. So all we need is s sub y over s sub x. So let's go ahead then and compute s sub x. So we want s sub y over s sub x. So let's do the s sub x and then the s sub y. So in order to do that, what I'm going to do is I'm going to highlight the x column. So I'll click on my mouse on the here and scroll down and make sure that I've captured all the values. So let's scroll down and make sure that we've done that. And I don't believe I have this last value of 0.460, so let me go back up again and grab that. So we'll go ahead and make sure we've grabbed all those data values. And then we'll hit S for the sample standard deviation, and we get 12.5183597. So I'll go ahead and store that value. Let me make sure that I captured them all. I think after I hit store, I lost it. Let me just make sure I had them all. So 57.56 to 14.6. Very good. All right, so hit S. I didn't have that because that was a different value. So I got 13.273. So let's store that. And then now we're going to go ahead and highlight the Y values. And then find the sample standard deviation. Oop, I forgot to clear the other value. I had that stored S sub X. I forgot to clear it. So sure enough, I start at 2.41, end at 0.51. I'll hit the S key. So that's S sub Y divided by S sub X, which is what we did first, times B1, and that was 0.898. And let me just double check to make sure that I got that correct R value. Yes, of 0.898. So there's our R value of 0.898. So it's S sub Y over S sub X times 0.898. And then we hit equals. And that gives us a 0.04, which is a very small slope, but it's positive nevertheless. So let me just double check to make sure I had my formula correct. Yes, it's R times S sub Y over S sub X. We put the S sub Y over S sub X first, but either way it's equivalent because of the commutative property with multiplication. All right, so let's enter that value in for the slope. And I noticed one student actually copied the values. So if you hit Control C, and you can also paste it in as well. On the older version of Alex, you could actually, there was a blue arrow on the calculator that you could paste in. I don't know why they got rid of it. All right, now to find the Y-intercept, that's B naught, and we go to list of formulas, they'll tell you how to find B naught. So under list of formulas, B naught, which is the Y-intercept, is given by Y bar minus B1 X bar. So we've computed B1 from the previous example. All we need now is the sample mean for the Y values and the sample mean for the X values. So let's go ahead and do that. So let's go ahead and find X bar first. So we're going to go ahead and highlight the X values. And then we're going to find the mean for that. And we'll go ahead and store that. And then we'll highlight the Y values. So let's clear that out and highlight the Y values. And that'll give us the mean, X bar. So that'll give us the mean for the Y values. So it's Y bar minus B1, which was 0.041, times X bar. And let me just make sure that 0.041 is correct. It might have been 0.014, so let's double check that. So the slope was 0.041. So to at least 3 decimal places. Okay, and so then we'll go ahead and put in our value, and so it looks like negative 0.002. So let's look at the line to see if that looks correct. So when we look at a line that we think that best fits those dots, is it going to be just a little bit below the x-axis at a negative 0.0002 2000ths? It looks like that might be just about right. So we'll find out in just a minute, won't we? Didn't I say negative? Or let me grab that calculator. I thought it was a negative value. Did I lose the calculator? Oh, here it is. Yeah, it was negative. Alrighty, so I'll be doing another movie called Part 2, What to Do When We Have the XY Column.